Okay guys, we're getting started with chapter 4. It's all about sequences and series. A sequence is just an ordered list of numbers, and we keep track of these numbers by their position in that order. So we've got a first term, a second term, a third term. We use n to count. So sometimes you'll see smaller numbers up above. That's our n number. And here's the second term of the sequence. There's the third term. Here's the fourth term, and then somewhere down here we'll have like the nth term, and sometimes we'll have patterns that will find any particular term, so we'll use the letter n there. So write the next three terms of this particular sequence. Well, sometimes they're pretty straightforward. I would recommend that you study them by doing carets, where you just look at the difference. Here the difference is a +7, it's going up by 7. Each time it's going up by 7, so this gets to be kind of trivial. 34 and 41, okay? And we'll learn how to make formulas and find that nth term later, but right now we're just talking about some basic terminology. Here we've got a sequence that's going from 0 to 2, 2 to 6, 6 to 12. If we do carets here, we might not see that there's a constant right away, but we will find a different pattern. That's 6 and that's 8. So it looks like the caret numbers are increasing. If I did carets of carets, I would get a constant 2 in there. So I can say, all right, well this is going to go up by 10, so that's 30. This is going to go up by 12, so that's 42. And that'll go up by 14, so that's 56. And you'll see, again, we can find a pattern that will predict the thousandth number without doing all first 1,000 later. This one, what's the pattern here? And any time you can pause the camera and you can take a look at that, see what you think the pattern is. 4 to 2, 2 to 1, 1 to 1/2, 1 to 1/4. It's not rocket science. I think you guys can get it. It's 1/8. It's 1/16. Right? The numbers are doubling. Sometimes people make the mistake of going 2, 4, then writing 6 and 8 and 10, but it's 1 over 32 right there. Okay, and at this point I want to introduce the concept of a limit, since it is up here as our topic for the day. And this is a term that will come back with a vengeance in calculus and even pre-calculus. We're looking at what is this sequence approaching each term? What number might each term get closer and closer and closer to? So 4 to 2 to 1, is this getting closer and closer to a particular number? It's going down, but it's never going to get negative. It's getting smaller by half each time. So it's getting closer and closer and closer to 0. So we would say the limit of this sequence is 0. That is the number it's getting closer to. Will it ever get to 0? Well, not in an actual term, but in infinity it will. So our limit is 0. This last one here now, again, you can pause the video and see if you can figure it out. There's a little bit more to this one than the other ones. Okay, so pause me. Alright, we're back, and this has a simple answer of -7 when we reduce that. This is -3, this is -1, and this is 0. But carets don't really help us in this sense. But if we look at the bottom numbers separately, and in this case they're doubling, so this is going to be 32, this is going to be 64, this will be 128. The top numbers, however, what's happening there? They're just going up, in this case, in comparison to these numbers, they're always 16 less. 16 taken away from 2 is -14, 16 difference there. So the carets, in a sense, need to be between these numbers like that, and you'll see it's 16. The caret there is -16 as we go up above. So this is going to be a positive 16. This 64, take away 16, we'll get 48. And there, take away 16, and we get, what, 112. Well, that's easy enough to find, but now what's the limit? So ask yourself, what's the limit of this? Here it's going to 0.5. Here it's going to 0.75. And I'm not even going to attempt to simplify that one. You can do it easily enough, but I don't want to do it on camera. You can simplify it. But also think about what happens as this gets much, much, much larger. We know from that day when we were doubling grains of rice on the calendar that when you're doubling things, they get big really fast. And if you wind up with a huge number, and all you're doing is taking away 16, think about the ratio of those two numbers. And when we get up to 1,000 or 1,000,000, it's just going to be 1,000,000 down below, something really big, right? Some huge number. And then we take away 16, and we're very close to the same number up above. So the limit of this is getting closer and closer and closer to 1. It's going to go to 0.9 and 0.99 and 0.999. You can try to even go out 20, 30 terms, and you'll see it gets ridiculously close to 1. All right, so that's the basics. In the book, you'll see that this is pretty close to problem number 20, I think it is. Problem number 24. All right, so you're well prepared for class if you have studied and understand that.